Hi, ladies and gentlemen. Welcome to the new episode of DSPy interview series on Information Shelf. Today, we got two really young founders with us, Farouk and Tyrin. They're building Modaic, which is a platform for packaging and distributing DSP programs. I mean, think of it like Hugging Faces for DSPy. Farouk and Tyrin, welcome to the show. How are you guys doing?
Doing great. Yeah. Happy to be here.
What's Modaic? How did you guys get to meet? And what's the backstory? Why are we building this?
So about 2 years ago, me and Ty met at a General Catalyst event, just a VC event for young people interested in entrepreneurship. I thought Ty was extremely talented, and I guess he thought so as well. So we got each other's LinkedIn, and we stayed in touch. Over the summer, I contacted him just for some coffee, and we decided we were going to build together. So we're just throwing ideas at each other. Ty was working on video models at the time, and I was working on MCPs.
Okay.
So I was using DSPy specifically at one point when I realized the whole like prompts don't scale thing. I was like, okay, how am I measuring like how I'm actually improving? How am I measuring success within my RAG pipelines? So I had heard about DSPy like a year ago from a friend. He mentioned it. I didn't really think much of it. I just kept a mental note of it just to tab it. And then when I had faced this problem, I was like, okay, like maybe I should like check this out again. And I guess this is like the same like thing for a lot of people. It's like you see DSPy and at first you're kind of just like, okay, what's the point? Like, what is this? And then you actually try it out and then you join that almost like cults of it, like the DSPy community. Like it's just like you like the philosophy is just so like ingrained in your mind now. So I was like, wow, DSPy is great. I was in love with it as well. So at first I was just using DSPy to optimize my RAG pipelines, but Ty was like, okay, well, this is almost like it's modeled after PyTorch. Like it's very similar to PyTorch's syntax. And it's almost this new paradigm for how we interact with LLMs, right? So we thought, okay, with PyTorch came Hugging Face. Hugging Face is almost this like democratization of the primitives that PyTorch introduces. We thought DSPy needed a similar platform to lower that barrier of entry that's required to use it. So at first we were just like, okay, let's start out with the simplest possible version of this. So Hugging Face started out with just being able to package the weights of your model to be able to run that either internally within your own company or to open source it as well, like for other people to use. So obviously Hugging Face when it started was just like this little community, but now it's like the driver for everything open source AI. So the main problems that we were trying to solve with DSPy that we found that would apply to the most people is that the data ops required to run an optimization is extremely extensive. Like for a small team or like even a solo dev, getting that golden set for a JEPA run is very, very hard. Especially when you're running it, in production. You know, the Hugging Face has a bunch of data sets out right now for like very like simple like classification extraction tasks. But for AI systems, it's a lot more like detail than that. You know, you have traces that you're now grading.
Right.
How am I getting those traces into the optimal format to pass
Mm-hmm.
into a JEPA, into a
Repro.
MIPRO, you know? Yeah. So that's one side of the coin. And then the other side of the coin was that, okay, so now DSPy exposes its primitives in a way that it makes experimentation extremely easy to run, but it doesn't change the fact that you now as a software engineer, if you don't
Right.
have an ML background, need to change this mindset from software engineering to being more data oriented, to having like this like researchy mindset to how you run experiments, you know? And we believe that the only like commoditization or like democratization of such is open source. So, you know,
Makes sense.
DSPy is just like a set of, it's just a program, right? A DSPy program is just a program.
Mm-hmm.
A compilation or a conglomeration of DSPy programs is software, it's AI software. So where Omar Khattab described as like AI systems. And as GitHub was like almost this like democratization of like code as traditional lines of code, we want to be the democratization of AI software. How people define their systems, how people define their metrics, and how
Mm-hmm.
people are able to get this golden set to now run into an optimizer.
Makes sense. And, when I was looking at Modaic, I was like, I could visualize that, it would be super useful if you have packages which are domain
Yeah,
specific and you also
yeah,
belong to the same
yeah,
domain. So,
yeah,
so then it just cuts short your time to kind of build the same thing again.
yeah,
And
exactly.
I think
It
broad
becomes
domain.
like a computer science. It becomes like a of one problem, you know, like your solution's already there, like you're 90% of the way there. So now you just have to optimize it on your data to get it like 100%. Or you can create like even like company specific like DSLs within like that's what package like regular package managers are like for that like pip. an NPM. They're created so that your systems are more maintainable and that you're choosing the abstractions that you want to use. And so like if we're in this world where DSPy is a standard and declarative AI programming is like what we want like everyone to be using, we're trying to build the base almost for like the infrastructure for how this
Got it.
AI software will be maintained.
Got it.
Yeah.
Awesome. So Tyron, would love to know a little bit about you and your backstory as well in terms of what excites you about this work and, what areas of Modaic are you contributing?
Yeah. So I guess rewind to like when Farouk and I first met, which was like summer 2025, so not that long ago.
Yeah.
Basically, I was really deep in the weeds and like a lot of like AI research.
Okay.
So like Farouk said, I was working on like on video models. And so that kind of led me to working a lot with like Hugging Face.
Right.
And I was working on this video model. I needed like to pull this. Video models are like kind of hard because they use video data, which is
Right.
like very large.
Correct.
So I had to work a lot with like the Hugging Face datasets library. Basically, as I'm doing this, I'm like looking through like the actual like source code of the library, and I see that like they're doing some things wrong, and like they could be doing some things better,
Right.
that could like help me process these video and audio data. And so like I made like a quick PR, and that was like my first PR to like any open source library. And I just like I love the process, and so that's kind of like what got me obsessed with like first of all like AI models, Hugging Face, and like and open source. And so when Farouk told me about DSPy, and I kind of saw like the parallels.
Right.
That's like what really got me excited was kind of building like doing the same thing that Hugging Face did for ML,
Got it.
for DSPy programs and AI software.
Got it.
So that's kind of like where I started out, was building the Modaic SDK. And because I had spent so much time in Hugging Face and like studying how that system worked,
Right.
I just applied like the same concepts to building up the Modaic SDK and the abstractions that we use to version control and package DSPy programs.
Got it. So
Yeah.
Tyron, taking what you just said a little further. So I was looking at Modaic, the SDK, and Abhi, and I think the two of the big workhorses for you are the pre-trained model class and the pre-model config class. And I think there's a pre-compiled program class, right? Those two kind of help you package and distribute. Wondering, if maybe Farouk, you can show a demo, and then, you can dive deep and just tell how under the hood this is, sort of getting packaged and distributed.
Yeah. I can real quickly explain like what those are, and then
Sure.
Farouk can show a
Do you
demo.
want to do the demo first and then go to kind of the code? Yeah. Awesome.
Sounds good. Sure. Yeah. Let me share my screen. So I'll start by showing the platform. Okay, so as you can see here, it has a very Hugging Face-esque design to it.
Right.
So it just lists out all the programs that people have already pushed to our hub, and you can have private or you can have public programs.
Okay.
So we treat programs as you would treat like a Hugging Face model almost. So we think that the true unit of AI software is the LM plus the prompt, the artifact prompt that's being generated.
Right.
So on the left here, you have filters like DSPy, JEPA, and obviously we don't have the Rust port of DSPy like figured out for our SDK, but since it's just a Git server, like you would GitHub, you can technically just push like any arbitrary code to the platform as well.
Got it.
So if we hop into one of them, for example, let's just do like this one. So this was a Stanford researcher, the one who made the paper structured prompting for more fair evaluation for language models. As he was running evaluations, like benchmarks across the Helm, Stanford's Helm benchmark, he pushed all of the different combinations of optimizers plus LMs to the hub, and then was able to pull from the hub within our AutoProgram primitive to evaluate them as you would a regular DSPy program. So this is just like good maintainability. You get to see what modules are being defined. And you even get to like introspect as well, like what the artifact looks like. And then if you push to hub with code, you can see almost like a screenshot of the code when it was pushed to hub. And we make sure to like exclude like to include external and internal dependencies that are required to run that program, but nothing else that's not required to run that program. So any like extraneous dependencies within like your application's code will be ignored. Yeah. So yeah, if you go to your account here, you also have like organizations as well. And they work the exact same as like like a regular repository, except it's under an organization. So here I have like a self-hosted like SLM that I wrapped with a DSPy program.
Okay.
And I pushed the hub here. But then, yeah. So
When you say you wrapped a small language model, correct?
Yeah.
So
Yeah.
obviously the model itself is not here, but that needs to be hosted
Yeah.
by the person. But rest everything in terms of if you have a harness, or if you have like a planner, or if you have an optimizer, all that is kind of wrapped in, is what you're
Yeah, all
saying.
the scaffolding around the actual model is on our platform. But we plan to, well, we're thinking about getting into weights as well. We think it's like kind of redundant because Hugging Face has already like optimized for the weights.
Right.
But I think it's necessary because we think the future will be just like a lot of SLMs being run in tandem.
Okay.
And then you optimizing prompts across the whole global program. So optimizing prompts as well as optimizing the weights with either like a bootstrap fine tune or like a grpl.
Okay, got it, understood.
So yeah, so I'll
Okay.
give you a quick demo as well of the like actual process of pushing something to hub. So we try to make the process of pushing to hub like as seamless as possible. So like if you already have a DSPy program, like we want to make it as minimal steps as possible. So we took Hugging Face's concept of pre-trained model and replaced it with precompiled program. So precompiled program, all it does is extends DSPy.module, that primitive, and adds an extra utility class for pushing to hub. And then you just specify a repository path. So here you see I defined a signature. And then precompiled config is our like version of just like state for the experiment specific variables that are going into an optimizer or going into your program, like the LM, the number of tokens it can produce, the temperature, all of that affects the trajectory of like the outputs for your program.
Same thing as a pre-trained config from Hugging Face. Same idea.
Understood.
Here I have just an example of like a receipt extractor. So I have the signature set up to take in an image of a receipt as just a DSPy.image primitive, and then it should output the total cost of that receipt. So this receipt corresponds to this one right here. And we have the code set up here so that it takes the receipt and it runs it on the program. And then right after it should push it to hub under our org name. So I'll run this. Yep. So then it should have been created under the Modaic org, like I specified. And here it is. As you can see the code at the time of pushing, as well as the config that we specified, and then the program.json, which is just the prompt, the precompiled prompt. And then with AutoProgram, that's our primitive of like, it's our version of auto casual model from Hugging Face. So all it does is it runs an arbitrary program loaded from the Modaic Hub in one line of code.
Okay.
So all you have to do is specify the path. And you can, even if you wanted to, roll back from a specific tag that you specified in your in a push to hub, or like a git hash even. So this is a separate image. This corresponds to this image right here. So it should output 29.01. And let's see. Yep. So yep. 29.01. So we were able to run the exact architecture, the exact LM, and the exact configuration of that LM in one line of code. On a completely different receipt. So as you can see, like the applications apply to like almost anything that you can do with like a regular DSPy program in production or just for fun. And yeah.
Got it. I would love to see, Tyrin, if you can kind of deep dive into one of the classes that you have to import and walk us through like, how it's kind of implemented on a high level.
Yeah. So I guess we can start with precompiled program. So precompiled program, basically we can even click in if you really want the full technical specs. It's very simple. Like you can literally see it's a DSPy module in there, and it has all the same methods, but we just add this from precompiled and push to hub methods pretty much. And what those do is we basically kind of maintain some like Git functionality. And we maintain we have like a cache that maintains like a Git repo and syncs it with a Modaic Hub. And then Auto is a little bit more complex. But essentially what it's doing is it Git clones or Git pools that repo, and then it adds it to your Python path if there's any code. If there's no code, then you can pretty much just use precompiled program from precompiled, which just uses the code within your repo and it just pulls in the configuration from the hub. That's like a high level over.
Got it. So basically, you're leveraging on Git and DSPy modules, and modules default forward functions, override them, of implement your implementation like a hook before the user's forward implementation runs, right? Anybody who's written a DSPy module doesn't have to worry, just inherit those two classes, which is your precompiled config, precompiled program, and that's it.
Yeah, so we basically think that we've made the best method for versioning DSPy programs as well as optimization runs. So when you think about versioning, especially for something like ML or something ML oriented, you're usually doing some sort of checkpointing, which just
Right.
means that you're storing the weights in a volume in another service, such as like weights and biases, for example. And that's because weights and fine tuning and gRPO are extremely expensive. So you want to take care of your weights and make sure that you can roll back to a certain point if you have a decrease in performance. So we took that concept and applied it to optimization runs as well. This just allows it so that you now have DSPy programs as like the first class citizen within the Git platform that you're using. So you can push it to Hub, like in GitHub or in Hugging Face, right? But it doesn't treat DSPy, like the syntax, as well as like the compiled artifacts as first class citizens. So when you want to roll back, or you want to, try to like run it in one line of code, you now have to like find that artifact like within either your code base or like some like arbitrary Git repo, GitHub repo, or Hugging Face repo. So this just allows it for you to almost like capture the exact like control flow plus experiment specific variables. So that when you're doing all these rollouts and you're keeping track of your metrics, you know exactly what works and how to get to the exact same performance that you had at another point.
Got it. Awesome. So basically, Modaic is the PyPy plus Hugging Face for DSPy, right?
Yeah.
That's a good way to put. Okay, so I've got a question for Tyrin now. Tyrin, what other applications do you see for Modaic other than packaging DSPy programs?
Yeah, good question. So I guess like when we first started, we set out to like solve all the issues that kind of arise with like this DSPy workflow. Like DSPy, it solves a lot of problems. It basically makes this new workflow where you're only as new optimizers come out and as better models come out, you're basically only bottlenecked by how well you can define your metrics and your goals of success. And although that like solves a bunch of other problems, it creates like this new problem, which is like now you have to come up with like really good metrics of success in order to do this new like continuous optimization on your DSPy programs. And so we kind of, as we were building this platform, we kind of discovered that like DSPy almost like solves the problem that it creates, in that like, well, now you have like you can use LLM judges in like your optimization runs, right, to define your metrics. The issue is that they need to be aligned. And so you can actually use DSPy to also just like align your judges, and then use those judges to align your original program as well. So that is, to answer your question, that is where we're kind of heading with this, where basically we can now use this hub as like great like native platform for continuously improving your judges, so that they're aligned with like your preferences and with your users' preferences. So then you can actually use those judges to re-optimize like your programs, or you can just use those judges for evals. And it's all in like a DSPy native kind of way, which is really nice.
So basically, you would extend the test example sort of primitives that DSPy gives. Okay. To be honest, I'm not able to wrap my head completely around how this would come into play.
So the gist is, I can go a little bit more in detail into how it would work. So if you think about any like of the current observability providers like Braintrust or LangFuse or MLflow even.
Right.
So right now they're almost just like a place to store traces. Like, you log your traces there, and they give you like out of the box like scores. So these are either functions or like provided element that you have to give your own prompts to. So now the bottleneck is like, how well can I create a prompt that will capture how like capture the nuance within like human preferences enough to accurately grade inputs and outputs for my function of success.
So you'll need to tap into that as well. Like,
The
now
neat
it
part
kind of
of
makes
that
sense.
though is that you can define arbitrary code as a score, so functions. And we've made it so that you can run a DSPy program over network calls. So like within one line of code, you can run an optimized judge that we've created
Mhm.
within a brain trust or a lang fuse or an ML flow, and seamlessly like re-optimize like how it's performing. And if your preferences change, the way we've set up the algorithm is that we keep track of the confidence scores of the judge as well as its output. So anything that's below a certain threshold gets tracked and is staged for you to come back and relabel it yourself and then re-optimize the program towards that specific preference.
Understood. Got it. So basically, one would be like on a very high level, you're packaging LLM judges and you're going to pick up the traces to understand what exactly is the program that it's going to judge is actually doing and sort of optimize that.
Yeah.
And I'm assuming the user would also be able to bring some sort of or upload some sort of golden data sets or labeled this thing. So all of these three come at one place.
Yeah.
While I kind of understood high level what you're trying to accomplish, I'm really looking forward to kind of seeing how you make it as easy as your pre-compiled program and conf to sort of make this first class citizen. That I'm not able to wrap my head around, at least at this point.
Yeah, I
But I'm
can.
sure you guys know what you're doing, and
Yeah,
I would wait to learn from the actual code. Yeah, go ahead, please, Tyvin.
yeah. One of like the main pain points that we've kind of discovered as like we're talking to like a lot of these companies and a lot of people doing this is that like judges are like they're kind of weird, like they're very convenient,
Right.
in that you just send it to an LLM and it gives
Yeah.
you a score. But
Correct.
it's very hard to like trust like what a judge is saying, even if you have like a golden data set.
Right.
And then even if you do have a golden data set, like it's like you might have a situation where you have thousands or hundreds of thousands of traces, and it's just not like feasible to have your human annotation team like label all of those.
Correct.
And so what we've done is we've done like a lot of research into like making algorithms that actually judge your judges. So like evals for your evals, which is like, which, sounds crazy, but it's very simple. It's literally just like doing introspection into the judge itself to figure out like how confident it should be in like in a single trace, using you basically using like introspection into the model, and understanding like what is the likelihood that this trace is actually correct based off of previous labeled traces.
The idea is that this would also run at the Pareto frontier as well. Like you wouldn't be sacrificing on cost because we're using SLMs, right? So you can get an SLM to perform just as well as a frontier model with a little prompt optimization. And if we have to get into a little GRPO or SFT as well.
Okay.
But yeah, it would be like exponentially cheaper than running a frontier model on a very, very large prompt.
Awesome. Okay, so I got a sense of what more you guys are planning to do. So Farouk, like all this that you envision that you'll do, would you have some sort of like sandbox? Or like you'll have to come up with a whole pricing strategy for your product and etc. Correct? Because this would be compute intensive.
So
how does that work?
I think so I think we've kind of agreed that running either a pricing like a business model on the amount of traces processed or the amount of inference used. So we use Modal, and we're in between like Modal and Together AI. But the gist is that it's a lot cheaper to run SLMs than it is frontier models, but we need some way to cover our margins. Yeah, so we would charge like maybe like the same amount for inference plus like a couple cents per call, and then the amount of traces processed, like the volume that we're processing, is what we'd actually be like pushing. And then maybe if it gets into like now they have a lot of different judges, we can get into storage costs as well. So that's what it's looking like.
Got it. Awesome. So I think I get a sense of what you guys, like the roadmap looks like, and it definitely sounds pretty bleeding cutting edge. One more question. You guys have I don't know which one of you coded it, but you have a DSPy IntelliSense plugin. Do you guys want to talk about?
I can talk about that.
Yeah, that came from, so I don't know. I really like the typing library in Python, and I started like noticing like just things that kind of irked me about DSPy. Like I really didn't like that like when you make a signature, it doesn't like forward it to like a prediction to your prediction, so you can see like what types are there, or to your call. And so like I spent like a few days actually in like the DSPy like source code trying to like see of like some sort of way to kind of make that work. and I made a PR, but it was like very like half done, and there was like a lot of like kind of holes in like how it would work. Basically, like to make a long story short, like making it so that like that actually happens is actually like very hard to do with like the current like typing rules in Python. And so like it's probably not gonna happen anytime soon from what I can see. But then I thought about the fact that like libraries like Pydantic and like data and Python data classes, like they just like changed the language servers. Like just the language servers themselves changed to kind of
Correct.
accommodate them. So
Right.
I was like, well, I'm not gonna make a whole language server, but I was like, like it'd be cool to like just have like a little VS Code extension that could like kind of give you like a little bit of introspection into what's going on. So basically, it reads your signature and it tracks what modules that signature is getting passed into, and then it gives you little hints on your calls. So you know, like,
Calls,
okay,
yeah.
these are the inputs that this module takes in based on its signature, and then it'll also give you hints on the predictions that those calls returns. So it'll say like, it's, these are the output fields. So these were like the fields that will be a part of the prediction and their types as well. So that's basically what that is. And it has like 400 downloads so far
Right. I'm
across
one of
first
them.
string VS Code. Yeah.
Nice.
So check it out. It's pretty convenient, I would say.
Awesome. Okay. So I saw the extension, then I followed you on Twitter, and it's kind of embarrassing. It only hit me today morning. It's the same time. And so my apologies. All right.
All good.
So that brings me to the last question. What is DSTS?
Oh, okay. Yeah. DSTS. So like, I guess so. Yeah. We also have like Axe, and there's a bunch of other like kind of DSPy ports, to other languages. There's DSRS, DSRB, DSGo. So basically, TS came out of. I had a friend, and I was like preaching the gospel of DSPy to my friend.
Right.
He's like, sorry, I can't use it. Like we only use Node, for all
Right.
of our services.
Right.
And so I was like, it doesn't matter. Like, there's a port of DSPy in every language.
Right.
And so I tried to like implement it for him, but like, I think like with Axe, like I think there's like a very like specific like workflow that you learn when working with DSPy.
Mm-hmm.
And when I was trying to apply that to the other like DSPy ports in TypeScript, like I wasn't able to kind of work in that same like workflow and like how I actually like understood DSPy.
Right.
And so like I kind of set out to build like this TypeScript port of DSPy that's like an exact mirror of the DSPy library, like very inspired by like DSRS and DSPy Go. And so so it's basically it's a full like DSPy mirror. It uses the AI SDK as like a backend. And so it has adapters.
Right.
What was that? Vercel?
It's by that company called Vercel, right?
Yeah, Vercel.
Yeah, so use the Vercel AI SDK. So everything you can do with Vercel's AI SDK, you can also do with that. And then you can interact with Vercel's AI SDK through like a DSPy type of API. So it has adapters. There's adapters, just like the same exact adapters that you would use in DSPy, and it formats the prompts in the same exact way. There's signatures, and when you dump the state of a program, you actually get a JSON file that is the exact same format as like a DSPy. So you could even do like, if you wanted to, you could do like cross compilations. Like you can compile a program from DSTS and use it in an identical program in Python. And then there's LLMs, all the same primitives. So if you're familiar with working in the same primitives as DSPy, like it's basically like the same idea. It's just in a different language. And in the same way that DSPy uses Pydantic, it uses Zod for typing and validation. So like
at least I'm not aware about anybody else doing this in the DSPy ecosystem, and also the kind of roadmap you're thinking in terms of tapping into all these observability or open telemetry for that matter, and bringing evals and ability to sort of take your golden data set and optimize your, a judge to judge the LLM and make it better, like LLM judge and make it better. Can't wait to kind of try it out. And best of luck for the endeavor, and thanks for
Thank you.
DSPy IntelliSense as well, Tyrin.
Thank you.
Thank you.
Thanks a lot, guys.